Good morning to you all. I'm here today to talk to you about policy-optimized networks. I do work for Extreme Networks, and we are fundamentally an Ethernet switching company. We do a lot of innovative work in the field of Ethernet switching and more recently in software-defined networking. So while we are on this topic of networking, I want to take a moment and urge you guys to think about optimal user experience when it comes to utility. And when I'm talking about utility, I'm talking about water and electricity. Well, optimal user experience when you're trying to drink a glass of water, it's pretty straightforward, right? You just turn the tap, and with electricity, you just flip the button, and it just all works. You just always get the right experience. The question, though, is the network is also supposed to be a utility, but what about the optimal experience with the network? This is a picture of me Skyping with my parents in India, and where they live, they don't get any snow. So I was sharing, a video of snow in my backyard, and it was quite an emotional moment for them because obviously they've never seen it before until the video just froze because my husband was sitting in the living room and he was doing a lot of YouTube. Now, clearly, the network couldn't, discern the difference in priority, where one traffic was more important than the other. But I think fundamentally the problem is that the network was not able to adapt on demand with the right quality of service for the high bandwidth requirements of this application, right? Now, let's look at what happens when you apply that scenario to hospital networks, to healthcare networks, right? Now, when you're streaming voice, video, or data from a patient's bedside monitor or from infusion pumps, or you're just doing a telehealth video with your patient, right? At that point, a drop in packet or a latency, a network threat is just not an option. Now, a lot of people will argue that the state of the art, the way it is done right now, is, well, what if I keep my clinical data network completely separate from my non-clinical data network? So they're physically separate, there are a lot of firewalls, and since there is little sharing, there is little threat for a network attack, and hopefully little issues with latency. Now, anyone who understands network CIOs, network admins, and I'm sure a lot of the people in the room would agree with me that keeping these networks separate is a nightmare in terms of manageability, scalability, cost, right, efficiency. So if we are able to integrate all of that traffic on one single physically integrated network, it's a beautiful thing. However, we have to do it right. So when I say we have to do it right, we essentially are looking for three things, right? Number one, we want to be able to keep the performance of the critical user, like a doctor in a hospital, completely separate from the traffic of a non-critical user, like an unauthenticated guest. Number two, the network has to be always available and highly secure. And finally, number three, a critical user should have guaranteed bandwidth and quality of service when they need it. So we are actually asking for a network, again, that adapts on demand for the optimal user experience. And this actually is a truly very interesting time in the field of networking with multiple different inflection points in technology all coming together to deliver on that vision. So I kind of like to draw this analogy of a favorite painting of mine where if the network were Homer, this would be a moment of apotheosis for the network where it's kind of writing its own epic in networking with this paradigm-shifting technology, which I'm sure a lot of you have heard about, called software-defined networking, right? And SDN is a lot of things, but the most important and the most exciting thing really is the fact that a closed network stack up until now is breaking down into its vertical layers, and programmatic APIs and interfaces are being exposed all the way down from the hardware all the way up to applications, so application developers can take advantage of them and program the network, again, to provide the right quality of service to the right user at the right location. Right. So what we've done today is we've developed an application, a demo really, of a software of an SDN application specifically targeted for healthcare networks. And we call it Medelight. And what Medelight does is user experience is optimized based on what I call the 4 Ws. So who you are, right? What application are you running on the network? When and for how long? And what location? So again, applying that to healthcare networks, who you are. So if you are a doctor, your network traffic is completely isolated from a guest network traffic. So what goes on in the guest network does not impact your performance at all. What application you are running. If you're a doctor just accessing your patient records database, which is just pure text, you probably don't need that kind of bandwidth. But when you are doing a telehealth call with your patient, you need a lot of bandwidth. So the network will automatically reprogram itself to provision the right bandwidth when you transition from accessing your database going to a telehealth call. So that's the demo that we're going to try to show you guys today. So here we have our tree switch topology, which emulates the hospital network, and it's running OpenFlow 1.0. This switch network is controlled by a centralized controller, which is also an OpenFlow controller developed by Big Switch Networks. So we have multiple different users, a doctor, admin, and guest. A doctor and admin can get on the network authenticated via 802.1x, and a guest can access the network unauthenticated. The application at the moment is running on this tablet, so I'm going to just hold it out for you guys to be able to see it. So once the doctor and the admin are authenticated, they get access to different resources over this network, which in this case are emulated by these different virtual machines, a doctor VM, admin, and guest VM, each one of which, for the purposes of this demo, are streaming MP4 videos over Apache web service. We are also using a visualization tool called Hyperglance, which at any instant of time is going to, well, I'm running out of time. So I'm going to go ahead and show you guys the demo. So I am already authenticated, and as I hit so I'm authenticated to a doctor SSID, and as I hit the doctor button, you'll notice that it starts streaming the video from the doctor VM over at this screen. And a doctor also has access to the guest network, but not the admin. So if I hit the admin, it's not going to give me access. But when I hit the guest, it'll also start streaming the video over the guest network. And what essentially we are doing at this point, we have 2 separate virtual networks with differentiated quality of service and priority, one streaming the doctor video and the other a guest video. You'll also see the flow programmed provision on Hyperglance. The other thing you'll also see is that once so at this point, I'm going to ask my colleague Renuke to blast traffic on the guest network, at which point you'll notice that the guest video comes to a halt, but the doctor video still keeps going. The third thing that I wanted to show you guys is while the doctor video is still streaming, I'm going to automatically change the path from the doctor to video conference mode. You will notice that the flow reprograms itself on a lower hop count, higher bandwidth path over on the Hyperglance, the slides over there. And finally, I just want to add saying that the best user experience is really seeing things with your own eyes, but until teleportation is a reality, software-defined networking really promises to deliver on that optimal user experience in terms of on-demand, right quaz, anytime, anywhere access. Just want to end with that. Thank you, guys.